Here we've been presented with a beaker containing a given concentration of calcium iodide solution, and we've also been told the amount of substance in the form of moles of the calcium iodide dissolved in the solution, and we've been told the concentration as well. And we've been asked to calculate the volume to give our answer in decimeters cubed, and we've been asked to give our answer to 3 decimal places. So how would we go about trying to approach the answer to this? And in an instance like this, what other tools might we need? Now, one of the first steps we would need to establish is, well, what units have we been provided for our in our question? Do we need to do any unit conversion? You can see we've been provided the concentration in decimeters cubed, and we've been asked to provide the volume of the solution in decimeters cubed. From inspection, we can actually basically determine that, okay, well, in this case, we don't necessarily need to do much unit conversion on a volumetric level. And if we recall the formula that's relevant, this would be moles, right? So in mole is equal to concentration and that's in moles per decimeters cubed. So multiplied by volume. Okay. Yeah, let me just get rid of that brackets. And that's going to be in decimeters cubed. Okay. Now, beyond that, we also need to look at, well, what are we actually trying to get at here? In this case, we're looking for the volume, so we do need to rearrange this equation. If we do divide both sides by the concentration element, we would get the volume is the subject of this equation. So we can do diameter divided by the concentration. I'm just going to abbreviate that as conc like that, like okay, that's in moles cubed, and we divide the same thing here. So on this side, this cancels out and gives us 1, right? And on this side, we have effectively, we've got our volume. What we can do now is just rearrange this equation to make we put the volume on the left hand side just so it's a bit clearer. So the volume, as we recall, it's asking us for the volume in decimeters cubed, and that is what it is here anyway. Is equal to the moles in moles, not moles per dm cubed. The moles divided by the concentration. So that's going to be moles per dm cubed. Okay, so in this case, as we effectively figured out initially, we don't need to do any volumetric unit conversion. This makes the following steps quite straightforward. All we need to do is literally take the moles from the question. So that's going to be equal to 0.82, which is given in moles, right? So 0.82 divided by 1.69. And that will effectively give us our answer. So I would invite you to have a go on your calculator to try and work out what that would be. Now, what you may have come up with is 0.485 2071. Now, the question specifically asks us if we do have decimals, or at least when necessary, we should give our answer to 3 decimal places. So in this case, we would need to do some rounding, right? And that would then be in, we would then need to assign our units, which in this case, you can kind of infer that or deduce that, which in this case, we've already kind of got it here. So you've got moles here divided by dm³. So moles, I'm going to use that cancels out, and that would become 1 over. So that, if we write that out in a literal way, that's literally, I mean, we do have it here. I'm just showing you like how we'd get it from literally just from the calculation, but 1 over, that's literally like 1 over dm³, right? That is, I mean, that is what that says, right? Effectively 1 over dm to the minus 3 is basically this. And we know that if we actually do this operation, all we need to do is effectively flip this. This is going to be equal to 1 times the dm³ divided by 1, which is just that. So we know even just from that the units here is going to be dm³. So in this case, our volume is going to be 0.485 dm³. Okay.